Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and with me, as always, is the brilliant Sheila. Today we're diving into a crucial aspect of operating systems, storage management.
That's right, Victor. Storage management is a fundamental part of any operating system, and it's something that affects every computer user, whether they realize it or not. So, let's break it down for our listeners.
Absolutely. At its core, storage management is about how an operating system handles data storage and retrieval. It's like being the librarian of a vast digital library. The OS needs to know where everything is, how to access it quickly, and how to keep it organized.
Great analogy, Victor. And just like a library has different sections and organizational systems, storage management in an OS involves several key components. Let's start with file system management. Can you explain what that entails?
Certainly. File system management is all about how the OS organizes and keeps track of files and directories. It's responsible for creating, reading, updating, and deleting files, as well as managing the hierarchical structure of directories. Think of it as the card catalog system in our digital library.
Exactly. And it's not just about keeping track of where files are. The file system also handles things like file permissions, which determine who can access or modify certain files. This is crucial for both security and multi-user functionality.
Great point, Sheila. Now let's move on to mass storage management. This is where things get a bit more physical. Mass storage management deals with how the OS interacts with storage devices like hard drives, SSDs, or even cloud storage.
That's right, Victor. The OS needs to know how to efficiently read from and write to these devices. It also handles things like partitioning, which is like dividing a large storage device into smaller, more manageable sections. And don't forget about disk scheduling, the process of deciding the order in which disk I/O requests are serviced.
Absolutely. And as storage technologies have evolved, so has mass storage management. We've gone from slow mechanical hard drives to lightning-fast SSDs, and even distributed cloud storage. Each of these technologies requires different management strategies.
Speaking of speed, that brings us to our next topic, caching. Caching is all about improving performance by keeping frequently accessed data in faster storage. Victor, can you explain why caching is so important in storage management?
Of course. Caching is like having a small notepad where you jot down important information for quick reference. In computer terms, it means keeping copies of frequently accessed data in faster memory. This significantly speeds up data retrieval because the system doesn't have to go to the slower main storage every time it needs that data.
Exactly. And caching happens at multiple levels in a computer system. There's CPU cache, which is extremely fast but small, then RAM, which is larger but slower, and even caching on storage devices themselves. The OS needs to manage all these caches efficiently to ensure optimal performance.
That's a great point, Sheila. And it's worth noting that while caching provides massive performance benefits, it also introduces challenges. For example, the OS needs to ensure data consistency across different cache levels and main storage. This is known as cache coherence.
Absolutely, Victor. Now, let's talk about the final piece of the storage management puzzle, I/O systems. This is how the OS communicates with all the various storage and peripheral devices.
Right you are. I/O systems are like the nervous system of a computer. They handle the communication between the CPU and memory on one side and all the external devices on the other. This includes not just storage devices, but also things like keyboards, mice, and network interfaces.
And the I/O system has to deal with a wide variety of devices, each with its own specifications and protocols. That's why we have device drivers, specialized software that helps the OS communicate with specific types of hardware.
Exactly. And modern operating systems use something called the I/O subsystem to provide a uniform interface for all these different devices. This abstraction makes it easier for programmers to work with different devices without needing to know all the low-level details.
That's a great point, Victor. And it's worth noting that efficient I/O management is crucial for overall system performance. Poor I/O handling can lead to bottlenecks that slow down the entire system, no matter how fast the CPU or other components are.
Absolutely right, Sheila. And that brings us to the end of our overview of storage management. To recap, we've covered file system management, mass storage management, caching, and I/O systems. Each of these components plays a crucial role in how an operating system handles data storage and retrieval.
Indeed, Victor. And it's the efficient coordination of all these components that allows our computers to handle the vast amounts of data we work with every day. From saving a simple text file to streaming high-definition video, it all relies on robust storage management.
Couldn't have said it better myself, Sheila. And that wraps up our episode on storage management. We hope our listeners found this informative and engaging. Join us next time as we continue our journey through the fascinating world of operating systems.
Thanks for listening, everyone. Until next time, keep your systems running smoothly.